Hello everyone. This is the second part of tutorial about advanced animal system. And from the last part I've added possibility to drop an item from an inventory like this. I can now drop a tomato and so on. So what we're gonna do? Now our animal is able to see a player and navigate on a landscape. But it should be able to see uh, items with which we are taming it somehow. It cannot be done with a perception system, or maybe it can be done, but it shouldn't be done with a perception system, by the way. So how do how are we gonna add the possibility to our animal to see what's surrounding him? Uh, to add such possibility, we're gonna use an environment query system. So at first, let's create a new folder and call it EQS. And let's open it up. And here we're gonna create an environment query and call it EQS surrounding actors. So, and to show you how EQS works, we should also add some EQS debug or EQS testing pawn. Let's call it BP EQS debug and put it somewhere. Here it is. Also, we should select a query template on these actors that we've added, and let's select surrounding actors like this. What we don't see anything because our EQS is now empty. Let's open it up, and you will see just one node called root. It looks quite similar to behavior trees, but possibilities that we can do here are much lower, in my opinion. We cannot create custom generators and so on. So here we can generate some points. For example, if we want to add points in grid or in cone, that's how it looks like. Now our debug actor is generating some points in environment in cone shape. You can also generate them in other shapes. You have these generators, but we're not gonna use this. We're gonna use a generator called actors of class. Here it is. The one problem here is that it only gets one actor and we cannot customize it. So we don't have a parent class for all tames. We don't, our actors can be configurable. Actors that can tame an animal can be configurable, and the problem with NQS, maybe I don't know how to do that, but we can't, for example, bind it or pass it here as a variable. So here we should define which type of actors we're gonna search. In my case, we're gonna search an actor, just an actor. Here we can bind a radius, but we don't need to do this. And here we can provide a radius. Let's make it 750, for example, and let's see how it looks like. Here is how it looks like. Oops, I'm sorry. It finds every actor that surrounds it. Here it finds fox. Here, if I will move a little bit from right, it will not find it because it has some radius. Well, by the way, we need to be able to score somehow. For example, let me add two tomatoes here. BP tomato. One is going here. Second one is going here. And let's move it a little bit. Here he found 2 tomatoes, or even I'm gonna place one here. Our animal will know that there are 2 tomatoes, but he should know, logically he should firstly go here to the closest one. So here is a scoring system comes in, and we can add some tests to filter or score our dots that were created. So let's add a distance test, and let's see how it works. Let's make it score only without filtering, and the one that is the farthest from uh, tester, let's call it tester, has a score of 1, and the closest one has less score, 0.38. We need an opposite, so we're gonna change the scoring factor. It's not gonna be 1, it's gonna be minus or 1, like this. Now the closest one is an actor by itself, by the way, and the closer we are getting to an actor, its score increases. Well, what should we do next? I think that score is changing a bit more fast. So let's make it not linear, but maybe square. Okay, doesn't matter by the way. We don't even need scoring, I think, but we will see. So let's save all, and let's navigate to our behavior tree. Here is our behavior tree, and we have to decide where we're gonna check this. This EQS is not running every tick. We should run it manually. So when we're gonna check a surrounding, we're gonna check it only in idle state. So we don't want to search for some food when we're running away from a player or attacking it. We only need to do it here when the behavior is idle. So let's increase this section, and we're gonna have a selector. We should select whether we just roaming around or whether we go in and eat any food. So selector will have 2 sequences. First sequence is gonna be roaming around. Let's connect it here, here, and here. And we're gonna have a second sequence. And let's call it eating. And this one is gonna be roaming. So what is the condition of selecting? We should check if currently some of tame actors exists in a radius of search. So we have to run an EQS check. But where should we do it? We can do it as a task. For example, we can do it as a task somewhere, but that's not our variant because by default he will be walking, and then it will be waiting. But we need to check it, for example, every second or every 2 seconds, and not when waiting of 40 seconds completed. So we have to add a service. We can just right click, add service, and run EQS, and select an EQS that we want to run. Also, this will not work for us because we have to filter all actors. We have to filter them and find only actors that fit us. So let's create a new service. and call it bt service run, no, EQS, or just find tames round. And let's override the function. Let's override, we have to override receive tick AI. Also, we have to override receive activation AI. What we're gonna do in receive activation AI? We have to know about classes from our configs that we've created in previous videos. So let's get control pawn and cast it to bp animal parent. Get config, break it, and here we have a data table and the row name. So let's get data table row with this row name and break this row. Let's break as animal config. And an animal config already contains a tame config that we're gonna break, hide unconnected pins, and if an animal is tameable, then we're gonna promote tame items to variable. Let's just leave it tame items. Now, every tick we're gonna run this EQS. So let's just run EQS query. And query is gonna be an owner controller. Run mode is gonna be all matching items. And we're gonna get query results as actors. Here it is. Now, if it is valid, oh no, we don't even check this. We're gonna loop through every actor. So let's for each loop with break. Here we're gonna get a class of our actor. Get class. And check if tame items, get tame items, contains this class. And if it contains, then we should add a new variable, call it tame, and it's gonna be an actor like this. Then we're gonna set tame to this actor and break from a loop. Next, on completion of this for each loop, we should set some Blackboard key. So first, let's create this Blackboard key object and call it visible tame. And it's gonna be an actor. Save back to behavior tree and open back service. Let's add new variable and call it tame key of type Blackboard key selector. And it should be a public one. Now we're getting this tame and set Blackboard value as object. Here it is. And value is gonna be a tame. Now, what should we do? What should we do? That's all. Also, we should make a condition. We should not set a new tame if we still have previous one. So let's get a tame key, get value as actor, check if it is valid. Is valid. If it is not valid, then we're running query. If it is still valid, then we're not running it. Okay, compile and save. I think that's all for this service. Now let's open behavior tree and add the service. This service also should run only when state is idle, so it should run here. Add service, bit service find tames around. And it should tick every, for example, 1.5 seconds without any deviation, like this. Then we're going to selector, and now we can define whether we should roam or eat. So let's select roaming and add a decorator. Decorator is going to be a blackboard. And in this decorator, we're going to check if visible tame is not set. If it's not set, then we're going here. And we're gonna observe aborts. We're gonna abort everything here if tame was found. So now back to eating. Let's just copy this and paste it here. And here we're gonna check if it is set. If it is set, then we're running it in sequence. For now, let's make it just simple. Move to and select an actor where we want to move to. And the actor is gonna be visible tame, like this. So let's test it out. Here is our fox. Let me put some BP tomato. Let me put some tomatoes here, 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 and here. Also some on the right and some on the left. And play from behind. Service didn't start yet. Let's, okay, service didn't start, so let's make a little change. We will also run this EQS query as soon as the service starts. So we're gonna run this right after an activation also, like this, and start it again. Let's debug EQS. Okay, I don't see any EQS running, by the way. Did I select? Oh, on run EQS query, we forgot to select query template. So let's select EQS surrounding actors and run it again. Also, I'm gonna debug EQS. So by the way, it sees these tomatoes, but it doesn't, of course, because let's open behavior tree and select our service. We didn't provide a key. We didn't set a key for a tame. It's gonna be a visible tame and not self actor. Okay, let's give it one more try. Okay, I don't know how, but it sees us. Oh, it saw us. Play from here and debug EQS. Let's wait until its roaming will end. Oh, it decided to attack me. By the way, why didn't it find, why didn't it run as a sequence? So visible tame is not set, then we're importing all. Let's open back service. Here we have every tick. We're checking if it is not valid. Running in EQS sequence. Getting a result. And let's add a breakpoint here and run it again. Okay, it tries to set some class unknown. Why it is unknown? Call fun get query results is result actors num 0. Okay, next 0. Next 0. Oh, return value false. Get query results as actors is failing. So why it fails? Oh, it fails if there are no valid results. Okay, let's open our EQS and disable distance check, for example. Will it? No. Still false. Okay. I found out some issues that we've made. I'm really sorry about it. So we don't need to do it like this. Also, let's add a control pawn as a query, not an owner controller. So EQS query is not a synchronous check, so we have to bind some event when it finished its work. I really forgot about it. So let's bind event on when query finished, like this. And let's add a custom event here. Call it query finished. And here we can get an actors get query results as actors. And only after this we gonna do something like this. Now let's test it again. I will add a breakpoint one more time and start from behind of a fox. Yes, and as you can see, it found us a tomato and it sets us this tomato, sets this tomato into our blackboard. So let's remove a breakpoint. So it saw a tomato and moved to it. So I don't see it, by the way. Where is this tomato? And let's debug EQS. Oh, there is one. Here it is. Here is a tomato under a leg of a fox. So here is the logic how it can find food and move to it. Also, let's increase an acceptance radius from 5 to 30 and save it. Well, what should we do next? We should be able to eat it, so we should play some animation, but unfortunately, I think that my fox doesn't have such animation. Yes, it doesn't have an animation for eating. Maybe I will add it later. Well, let's decide that we have an animation. We have to destroy this actor. So let's create a new task and call it eat tame. Here we're gonna add an event receive execute AI and finish execute. Here we can also play some montage if you have. I don't have it, by the way. So we should provide the tame to eat. So it should be a variable tame and it's going to be a blackboard key selector. Also, we should be a public one. So what we're going to do, we're going to get tame and get value as actor. Check if it is valid. And what we're going to do, we're going to destroy it, destroy actor. And finish with success. Also, we should get this name and set Blackboard value as object to nothing so that our service will be able to find a new tame. Now let's call this task from here, bt task it tame, and play from here. Now it moves to a tame. Oh, unfortunately I've destroyed, I didn't provide, as you can see, I provided self vector instead of visible tame and a fox destroyed itself. So don't forget to change the key. Now let's start again. Oops, almost sees us. Oh, I got too close. Also, let's move these tomatoes a little bit upward because I cannot see them. Like this. And play again. So here it ate this tomato, started to roaming, found me, and tries to kill me. So that is the basic of how eating and taming will work. Also in future, I think we're gonna replace this with smart objects because currently we have one fox, but we don't know how to deal with it when we will have two foxes, for example, and one tomato, and smart objects will help us. Thanks for watching. Hope it will help someone.